Hey guys, we went over limiting reagent or limiting reactant when we did our warm-up today. That's how I taught you limiting reagent. It's really simple. It's just two givens and two stoichiometry problems. But I wanted to kind of iterate how to find the limiting reactant in the problem, and then I wanted to elaborate on that with some information about the excess or leftover reagent. So, just as a reminder, if you are given, if you see two givens, you're just going to do two stoich problems. Okay, so today we did that with our warm-up. You want to identify which reactant, this is important, produces the least product. Okay, if you do two stoich problems and one produces 5 grams of a product and the other one you could produce 10 grams of a product, obviously the one that gives you 5 grams, you're going to run out and you won't be able to produce any more product. Okay, so that is called your limiting reactant or limiting reagent. This product will run out first. This reactant, will limit the reaction, and it's called the limiting reagent or reactant. Okay, the other reactant is the excess reagent. It is what is left over. So if you were to add more limiting reagent, your reaction could continue since you would have excess reagent left over. Okay, so this is where we stopped today. We did two stoich problems, we identified the limiting reagent, and I told you that I wanted you to watch this video that I'm going to upload in a moment, and I'm going to send you a reminder that it's up. Okay, but let's talk about the excess reactant. We are going to ask you some more questions about that. We might want to know how much was used or how much is left over. Okay, so we're going to be doing on page 3 of this practice packet, we're going to do numbers 1 and numbers 7. Okay, so hopefully you're jotting these notes down and working these practice problems with me. Okay, so I've already gotten the first few parts to number 1 worked out because it's simple. This is what we did in warm-up today. Okay, but just to reiterate, it gave me a balanced chemical reaction. Always make sure it's balanced. It told me a given for ammonium nitrate and a given for sodium phosphate. Okay, if you see two givens, do two stoichiometry problems. All right. So that's what I've done here. I'm going to fold this in half. So it wants to know what is the amount in grams of each product that can be formed. I, for the sake of time, only did two stoich problems and solved for sodium nitrate. Okay, you could pick sodium nitrate or ammonium phosphate. So I solved using my 30 grams of ammonium nitrate given and my 50 grams of sodium phosphate given. I solved all the way to grams for sodium nitrate. Just to remind you, when you are doing stoichiometry, you're doing it as a conversion with dimensional analysis. Open up the next conversion, drop your units. This is the molar mass for ammonium nitrate. Put moles on top. The minute you drop moles of your given on the bottom, that should be your red flag that you are in your mole ratio conversion. This is where you use your coefficients. I have 3 moles of ammonium nitrate and 3 moles of sodium nitrate. This allows me to switch from my given to my wanted. the only time you use your coefficients. Okay, now I'm in moles of sodium nitrate and I wanted grams, so I just go one more conversion. And I get 32.3 grams of sodium nitrate produced from 30 grams of ammonium nitrate, and from 50 grams of sodium phosphate, my other given, I did all this stoic, and I got 108 grams of sodium nitrate. Okay, so with one reactant I can produce 32.3 grams, and the other I could produce 108. I have to stop here. I run out of reactant at 32.3 grams. So this is my limiting reagent or limiting reactant. Okay? We learned this in class already. This is then called your excess reagent. It's left over. It's still sitting in the beaker. So B, what is your limiting reagent? It is your ammonium nitrate, your 30 grams of ammonium nitrate. C says determine the mass of the excess reagent used. This is where we stopped. We did not do this in warm-up. Okay, so this is new. What you do for this, to calculate the mass of the excess reagent used, do a stoic problem with your limiting reagent. Okay, so you are just going, oh man, that's not a very good line. You are just going to convert your limiting reagent and determine how much sodium phosphate is used up with that. Okay, so you're going to do 30.0 grams of ammonium nitrate. Drop your units, use the molar mass. You've already calculated it, so that's cool. Now I'm dropping moles of my given to the bottom. And this is where I switch to my moles of wanted. I want this reactant. I want to know with 30 grams of ammonium nitrate how much is reacted of sodium phosphate. Okay, so my mole ratio is 3 moles of ammonium nitrate and 1 mole of sodium phosphate, because that's my other reactant. Open up one more conversion. Okay, and 1 mole on top. Ooh, I'm getting a little sloppy. Okay, so I've canceled out grams and moles, and I'm in, guys, oh my goodness. Sorry, I'm rushing. I need to get out of here to take my kids to swim team. Switch those. Okay, you should have moles on the bottom and grams on the top. So when I do all this math in my calculator, it'll be 30 times 117.96, right? Because that should be on the top. Divide by 79.024, divide by 3, and I got 14.9 grams of Na3PO4 used. Okay, so to calculate the mass of your excess reagent used, you just do another stoic problem. Always start any stoichiometry with your limiting reagent if you know it. Okay, that's important to remember. Little tip. If you know your limiting reagent, use that for all stoic calculations. Okay, that's going to come into play when I teach you percent yield. Okay, so your answer to this one, determine the mass of excess reagent used or reacted, it's 14.9 grams of sodium phosphate. Okay, now I want to talk about number 7, and I picked this one because it asks on D for the grams of excess reagent left. Okay, this one asked for how much was used, and this one asked for how much is left. So we're just going to do the exact same thing, except we're going to have to figure out how much is left out of that given. Okay, so I'm going to flip over. I've already got this set up because I told you I would try to keep this video quick. Okay, so 7 says if you start with 14.8 grams of C3H8 and 3.44 grams of O2. So I've got two givens, so I knew I was doing two stoich problems. I did those, I set those up, and I solved with 14.8 grams of C3H8. I could get 24.2 grams of water, so I kind of skipped a couple of these. Right, I just went straight to C, determine the grams of water. And with 3.44 grams of oxygen, I could only form 1.55 grams of water. Side note, guys, do not assume that the one with the least amount as your givens is always your limiting reagent. Okay, this is just convenient that it happened to work out that way. Okay, so out of these two stoich problems, which one is my limiting reagent? Which one produces the least amount of product and will run out first? It's my oxygen, so I'm going to say limiting reagent for him. This is my excess reagent, my C3H8. And then it asks, determine the grams of excess reagent left. Cool. So when I want excess reagent, I'm just going to do a third stoich problem. And remember my tip, always start any stoich problem with your limiting reagent if you know it. Okay? So I'm going to take my limiting reagent and convert it to my excess reagent. Okay? So 3.44 grams of oxygen reacted with 0.948 grams of oxygen. No. Oh, my lights. Of C3H8. I'm sorry. Okay, so this is how much was used, but it asked me how much excess reagent is left. Okay, so take a second, see if you can figure that out. If I know I had 14.8 grams of C3H8 and I used this much, how much is left? Okay, so you just go one little extra step. 14.8 minus 0.948. You still have 13.9 grams of C3H8 left. So I just want you to be aware of whether you're being asked for how much was used or how much was left. Okay, how much was used? It's just that third stoich problem. How much was left? You do the third stoich problem to figure out how much was used and then figure out how much is left. Alright guys, so we'll do a warm-up with excess reagent tomorrow. You should hopefully feel okay about it by then. It's not difficult, it's just another stoich problem. Alright, have a good night.